This is section 9.1. We're going to be talking about variation. The homework for this section is 1 through 28. Before we get started, let's talk some definitions here. First, we're going to talk about direct variation. We have two variables, x and y, and they show direct variation if y equals k times x. K is called the constant of variation, and we say y varies directly as x. So here's what that really means. As one quantity goes up, so does the other. For example, the number of calories a person burns while exercising varies directly with the length of time they exercise. In other words, if you increase your exercise time from 30 to 45 minutes, you burn more calories. Inverse variation. Two variables x and y show inverse variation if y equals k divided by x. We say y varies inversely as x. As one quantity goes up, the other quantity goes down. For example, the number of hours it takes for a block of ice to melt varies inversely with room temperature. So as the room temperature increases, it takes less time for the ice to melt. As it gets hotter in the room, less time to melt. Joint variation is really kind of like direct variation. We just have many variables to worry about. So it's going to be multiplying, but we're just going to be multiplying by several variables. So joint variation occurs when a quantity varies directly with two or more other quantities. We say z varies jointly as x and y, and the equation would be z equals k times y times x. I'm going to be giving you some problems in the homework, and you're going to have to translate them into a math equation. So here's what that would look like. I would give you a sentence something like m, and it doesn't matter what that variable is, it varies directly as, let's say, t. So to translate that into an equation, we take this variable, m, varies directly, we say e, or equals k times, and then t is goes down there. So m varies directly as t, m equals k t would be the math equation. Varies jointly, so let's use another variable. Let's do v varies jointly as q and r. So the v varies jointly k times q times r. V equals k q r. Varying inversely, so what's another letter? Let's use n. Varies inversely as b. Varies inversely. You got to be careful with this one because I have the k on top of a fraction. The b goes on the bottom. N is equal to k divided by b. Write an equation. W varies directly as v. W varies directly as v. I'm going to have you do example 2 on your own. Example 3, m varies inversely as n. M inversely, remember we got to divide, and every variation question always has a k. You have to have a k in every single inverse equation. So m equals k divided by n. X varies jointly as y and z. X, always have to have the k. Varies jointly, we're going to be multiplying. X equals k times y times z. Make sure you read these carefully. So look at example 8. I varies inversely as the square of d. I varies inversely, k divided by the square of d. Notice I'm not saying square root, I'm saying the square, meaning I have to have d squared. I is equal to k divided by d squared. Example 9, d varies directly with the square root of L. Make sure you read it carefully. This time we do want the square root of L. And inversely with the square of t. So d varies directly. D equals k times the square root of L, square root of L, and inversely divide the square of t. So we need to square the t. Let's look at example 11. The gravitational force F between two objects varies jointly. So we know that F has to equal k times, because it's joint variation, with their masses m1 and m2, m1 and m2, and inversely with the square of the distance between the two objects. Steps for solving variation problems. First thing you want to do is write an equation, just like we have been doing. Next, I'm going to be giving you numbers to substitute in, and I'm going to give you two sets of numbers. So if you notice that one of the variables has two different values, there's a reason for that. You're going to use the first set to plug into the equation, and you're going to use the first set to solve for k. Once you have k, you're going to replace your k in your equation, and then you're going to substitute with the second set of numbers to find what it's asking for. So solve for whatever variable is asked for. So here's an example. If r varies directly with q and r equals 56 when q equals 7, find r when q is 6. So I have numbers before the word find, and I have numbers after the word find. I have two different values for q. I'm going to use the first set first and the second set second. So the first thing I want to do is write the variation equation. So it says r varies directly with q. So r varies, let me erase that. R varies directly with q. And r equals 56 when q equals 7. This is the first q. What we're going to do is we're going to substitute r and q into the variation equation. That's this. So we have an r value, 56. We don't know what the k is. We have to find it. And we have a q, which is 7. So we have to solve for k. We use the first set of numbers to solve for k. So if we divide by 7, k is equal to 56 goes into 7, or 56 7 goes into 56 8 times. So we found the k. We're half done. Half done. So we're going to take that k and replace it in the variation equation. So we had r is equal to k times q, but instead of k, we're going to replace that with 8, what we just found. Now we're going to take the second q value. The second q value after the word find is 6. So now I have a q is equal to 6. R is equal to 8 times 6. 8 times 6 is 48. And there's your answer. Many steps, but each step is easy. Let's do another example. N varies directly with m. N is equal to 72 when m is equal to 8. Find n when m is 5. Variation equation, n varies directly with m. We know that using the first set of numbers, we know that n is equal to 72 and m is equal to 8. So we have to use the first set of numbers to solve for k. And we get k is equal to 9. We're going to take 9 and substitute it into our variation equation. So now we have n is equal to 9 times m. Using our second set of numbers, m is equal to 5. 9 times 5, and our answer n is equal to 45. Let's look at example 15. W varies jointly as p squared and r. W is equal to 81 when p is equal to 3 and r is equal to 3. Find W when p is 2 and r is 3. So W varies jointly as p squared and r, and W equals 81 when p is equal to 3, r is equal to 3. So we're going to substitute those numbers in to find k. So 81, we don't know what k is, we have to find it. P squared times r is equal to 3. So we got to solve for k. 81, k times 3 squared is 9. 81 is equal to k times 9 times 3 is 27. Divide both sides by 27. And we get k is equal to 3. Another 3. Coincidentally, it doesn't happen like this all the time. So we're going to take the 3, the k, and we're going to substitute it in for k. W is equal to 3 times, my second p is 2, and my second r is 3. Remember order of operations, we have to square the 2 first, so 3 times 4 times 3, 12 times 3, or W is equal to 36. All right, the intensity L in watts per square meter of a sound varies inversely with the square of the distance. So I know the intensity L varies inversely as the square of the distance. At a distance remember was d, of 1 meter, the intensity, that was L, of the sound at a rock concert is about 100 watts. So we're going to use this first set of numbers to find K. So we know that L is equal to 10. K over, we know D is equal to 1. And we have to solve for K. So I square the 1. I have 10 is equal to K divided by 1. If that was any other number except 1, I would multiply both sides by whatever this number is. So let's suppose that was 4. I'd multiply both sides by 4. But multiplying by 1 doesn't really change much. So multiply by 1. So here we got 10 is equal to K. So I'm going to take my K and substitute it into my variation equation. And I've got L is equal to 10 over D squared. And now I need to take my second set of numbers. You're sitting 15 meters back from the stage. What is the intensity? So now I have L is equal to 10 divided by 15 squared. Fifteen squared is 225. We have L is equal to 10 divided by 225. That can be reduced. 5 goes into the top 2 times, and the bottom, let's see, 45. So L is equal to 2 divided by 45. And that's the end of section 9.1.